everyone. My name is Teck Guan, and I will be doing my presentation where I'm sharing my PowerPoint slides on Establish. So
Yes.
the zero knowledge proof that we are working on here is a quantum safe network. Just trying to get that slide. Okay, so it's a quantum safe zero knowledge proof approach that we're coming from, slightly different from a lot of the ZK snarks and all the others that you're familiar with. So I might have to spend a bit of time explaining that, but never mind. Let's get into the problem first. A bit about Establish. Establish is a product from PQC. PQC is the startup that I'm running, and our focus is really about building quantum readiness solutions for the future. Why is there a need to perform asset or ownership verification? I think this started back last year or even a year before, where we see certain bad actors within the Web3 space that started to use or started to take the assets that they had and used it for purposes that shouldn't be there, and therefore drove the need for organizations or individuals to demand that such service providers ask for proof that you own such assets or such tokens that's on the Web3 itself. So, and if the tokenization movement starts to grow even a lot more, where both tangible and intangible assets start to become tokenized, then there is a need for people to have to prove that they own these assets. It's slightly different from operating with a bank. In the traditional Web 1, Web 2 world, you leave your money with the bank, you leave some of your tokens with the bank, you leave your assets with the bank, and they custodize that for you. And in return, the bank offers you services because they know you have assets. When we move into the Web3 world, this is very different. It's all decentralized. You own your own assets and you hold your own assets in custody. But how do you then prove to people that you own these assets without revealing your address? That becomes a privacy issue that comes into play. The current requirements to prove that you own a certain address or own a certain asset is to publish your address and actually perform a digital signature. So what auditors and what many of the other regulators do is that they go to someone who purports to own a certain amount of assets and they ask them to perform a digital signature. You either do a dummy transaction online, on the chain itself to say that you own a certain asset, or you sign a certain challenge that the regulator auditor gives you to say that this is the key that you own. This is a problem because the transactions are very manual. The question is, can we do it for all addresses? And if every time I need to prove something, I get challenged and I have to create dummy addresses online, this starts to become a very weird operation that needs to happen. And if we want the world to move towards asset tokenization for anything and everything in the world, this form of challenging this ownership cannot continue. Because on top of that manual process, it also exposes the public key, which makes the address no longer quantum safe. And there's an entire lack of privacy because once we know which address holds which token, we start to be able to see all the incoming and outgoing transactions that happen. And this is totally going to make this whole asset tokenization Web3 movement a failure. So where do we come from? We want to say the web business wants to have maximum security, maximum privacy at minimum cost. The end user says, I want to know that certain businesses, or I want to know that certain wallets have certain addresses, but I don't want to reveal a lot of it. So how can we have a quantum safe, yet private, yet comprehensive solution to do proof generation in this whole Web3 world that we come from? And this is where Establish comes in. So what we have built, or what we are in the process of building, is a self-generated. So this is a non-interactive zero-knowledge proof for proof of asset ownership using MPC in the head. So we are using a zero-knowledge proof based on MPC in the head, which is a little different from the ZK snark technology that you are using. But by using that, we can allow for non-interactive, non-trusted setup, public verification of proofs without revealing even the public addresses or public keys or the addresses. The little website here shows a bit of this, but maybe I just jump a bit into the underlying technology. So that's MPC in the head. MPC stands for multi-party computation in the head. And the diagram you see on the right is essentially the very first construction of how it's done. To explain it easily, you are familiar with MPC, but MPC is typically done across multiple parties. MPC in the head is done by a single party, which generated several transactions, and then revealing only a portion of those transactions. And this gives us the ability to maintain both the zero knowledge and yet be able to give us the statistical bound to prove that you really know the information. So with MPC in the head, we're able to prove knowledge of pre-images of hashes. We're able to prove knowledge of a public key versus a private key, and several other operations that we are currently being built. So the benefits of AStablish, I think, is very clear. Proof generation can already be done, and this can be done off-chain by the person who owns the address in a quantum-safe, air-gap manner. So you have both security and privacy. The public key is never exposed during the verification, and the verification can be done on-chain and even can support cross-chain verification. I can do a little demo here, but I just did some screenshots for you all to see. So what we did on the Dfinity ICP chain itself is that we can already support a proof of knowledge of the public key. It essentially is a RIPE MD160 plus SHA-256 of a public key to generate an address. And if you follow through the process, you can enter the public key and it generates the proof that can be then put onto any public verification website that can do the verification for you. And all this is done without a need for a trusted setup. There is no issuer of the credentials. It is all done by simply the prover and the verifier itself. So we can do these kinds of things, and all of this information can be supported through the MPC and the head zero knowledge proof. Currently, what we are building is an extended version of this to support a proof of generation plus verification of address.
Thank you, AStablish team. I think time is up. Thank you for the presentation.